Hi, this is Miss Park, and today's video has to do with money. It's our first video of the financial applications unit. So it has to do with putting money in the bank, and there's different ways to earn interest when you put money in the bank. So when we put money in the bank uses our money for other things. And in return for us keeping our money with the bank, they give us some money on top of that. So they give us what's called interest. If we borrow money from the bank, so we want to buy something and we don't have the money, so we borrow from the money from the bank will charge us interest. So let's read here. When you deposit money into a bank account, you earn interest on your investment. So there's some new words here like deposit, interest, and investment. So investment is how much money you put into the bank. The bank pays you for letting the bank use your money. Your bank balance increases over time. So your bank balance is how much money is in the bank in your account. And when you save money with a bank, your balance will increase over time. Your amount of money that you have in your account will grow. When you borrow money from the bank charges interest on the loan. That means that the money that you have to pay back increases over time. So the longer it takes you to pay something back, the more money you have to pay back. So there's two kinds of interest that we're going to talk about in this video. The first one is called simple interest. Simple interest banks don't do. Simple interest is something that maybe a family member might charge you if you borrow money. With simple interest is calculated based on the amount of the original investment. So you'll borrow a particular amount and then maybe pay back a certain number, I don't know, whatever percentage every year. With compound interest, that's the other kind. This is the kind that we have in the bank right now. Interest is calculated on the amount that is currently in the bank account, which means if the amount that grows if the bank account grows, then interest is going to be calculated on the growing amount, not on what was originally invested. I'm going to show you the examples of this, so hopefully it'll make more sense. Okay, so let's do a simple interest example. So Dan deposits $100 into a bank account that pays 5% interest per annum. So the word annum means year. So every year, Dan's going to get 5% interest. Okay, so how does his money grow? So let's look at the simple interest example. In year 0, he's putting in the money, so he will have $100. Okay, 1 year later, year 1, he's going to have his $100 plus 5% of his $100. And so that's going to come out to $105. Okay, so his original investment was $100. He's going to get an additional 5% in the first year. In the second year, he's going to have his $105 that was in the account already after the first year, plus 5% of the original again. And if you put that into your calculator, that's 105 plus, now every time we have 5% of 100, that's $5. So this is going to be $110. Okay, year 3, he starts with 110, and again, he earns 5% of the 100, which is another $5, so that's 115. And then year 4 starts with 115 plus 5% of the original 100. So again, that's another $5, that's $120. Let's keep going. Starts with 120 plus 5% of his original 100, and that's $125. Okay, and so can we figure out in year T how much he's going to make? How much he's going to have in his account. Okay, so in year T, it's always going to be the original 100 plus every year he has earned $5. So in year T, he's going to have his original 100 plus $5 for every year that has passed, so plus 5T. Another way that I could write this is I could say it's his $100 plus 5% of $100. So let me write that as a decimal instead of percent. 5% of $100, that's the $5 times the number of years. Okay, so that's how the simple interest is growing. Let me contrast that with compound interest so we can see the difference. Okay, so with compound interest, he starts out with $100 investment. And after 1 year, he has his $100 plus, I'm going to start using decimals now. Here's your 5% of $100, and that makes $105. Okay, so in the first year, after 1 year, it's the same. But now here's what happens in the second year. In the second year, he has his $105 that he finished with after 1 year. And now he makes 5% not on the original 100, but on what's currently in the account. So what's currently in the account is 105. It means what's currently in the account already includes interest that has been earned in that year. And so we're going to calculate 5% of that money with interest so that the interest is being calculated on the interest. So now if you put this in your calculator, you will get 110 and 25 cents. So after 2 years is 25 cents more than if he had simple interest. Okay, so let's do the third year. So in the third year, he's 110.25 plus 5% of 110.25, which is 115.76. Okay, so you can see now he's got, with the compound interest, he's got 76 cents more than with the simple interest. And year 4, 115.76 plus 0.05 times 115.76, and that is 121.55. And then year 5, 121.55 plus 0.05 times 121.55 is 127.63. Okay, so you can see after 5 years, he's got $2 more than with the simple interest. Now this might look like very little difference, right? What's $2 in 5 years? But imagine that we're not talking about $100. Imagine that we're talking about major investments like, $100,000, right? So then with bigger numbers, those differences become more significant. Right, so let's put together a formula for simple interest. So simple interest looks like this. I'm going to give you some terminology with the formula. Okay, simple interest says this. Let's look at how we calculated at year T what we had. So the A, which we've used A before as the ending amount. So I'm going to write here ending amount. So we've used the A before in a different unit, ending amount. In other words, it's called the bank balance. So this is how much money you have in the bank, is equal to the beginning amount, which is the $100, and that has a name. The name is principal, and we write it with a P. So principal, I'm going to write it like this, principal, A-L, not L-E. The principal is the amount originally invested. Okay, so after T years, he has in his bank account the original 100 plus, this is the rate of interest, 5%, and times the principal, so 5% of $100 times the number of years that have passed. So I'm going to write it like this, plus P, R, T, and these are all multiplied. So again, this is the principal. There's your $100. And this is the rate. So this is interest rate. And it's expressed as a decimal. So we don't put a 5 there, we put 0.05 there. And T is the time in years. Okay, so that is a formula for simple interest. So make a note of this formula in your formula sheet. Okay, now there are other formulas that we could write that come from this one. So one of them is, if you want to know how much money he earned in interest, then it's just this part over here, right? Because the amount in his bank account is what he put in originally, his $100, plus whatever he has earned in interest over the years. So that's this part over here. So there is another formula that you might come across that looks like this. And it's just that interest part. So this is the amount of interest earned. Not the percentage, but the actual dollar value of how much interest has been earned. So this is another one. And if we put these two together, we can see that the ending amount is equal to the principal, which is his beginning amount, plus whatever interest he has earned. So really, simple interest has three formulas, but they all come from this formula. All right, you'll see they all go together. All right, so that's it for simple interest. Let's talk a bit about compound interest. I'm going to go to the next sheet here. So now, as we saw, compound interest is earned on the current bank balance, including any interest that has already been earned. Okay, so for example, Fran invests $100 in an account that pays 5% compound interest per annum for 20 years. So again, remember, per annum means per year for 20 years. How does her money grow? So let's do a picture. So on the other page, I did a table of values, but now I'll do it as a timeline. So show you a timeline. You've probably seen timeline before in maybe history class or English class. So I'm going to make a timeline. And why do they call it a timeline? Because it's a line, and we're going to put time on it. All right, so let me put time on the line above. So I'm going to put the time in years above. And below the line, I'm going to put the balance in dollars. So this is what's in the bank. All right, so at year 0 is the time that Fran is making the investment. So when the time is 0, no time has passed. She's just making her investment. Okay, $100. Now, 1 year later, her money has grown by 5%. So she's got her $100, okay? And it's times, so it's $100 plus 5% of $100. In other words, it's $100 times 1.05. So the 1 refers to the original 100, and then the 0.05 refers to 5% of that 100. Okay, so this is how we're showing that her money is growing every year. So at year 2, it's again growing by 5%, but it's this amount that's growing by 5%. So what we have is this amount times another 1.05. So at year 2, I have 100 times 1.05 twice. So it's squared. And all the way to year 20 will be 100, the original 100, and it has grown by 5% 20 times. All right, you may recognize this from before. What kind of sequence is this, where you multiply by the same number with every term? So hopefully you remember this is a geometric sequence. And what kind of growth is it? When we multiply by the same number each time, that is called exponential growth. Okay, so what is Fran's balance after 20 years? It's going to be 100 times 1.05 to the exponent 20, which is, a calculator, 265.33. Okay, so she puts $100 in the account. 20 years later, it's $265.33. Again, you might think that's not a big jump for 20 years, but yeah, what if it was $1 million, right? Then that would be more significant. All right, so let's write our formula for compound interest. It looks like this. It uses almost the same letters as simple interest. So A is the ending amount, so balance. I'll write ending balance, right? That's what's in your bank account, is equal to P, which is the principal, times what goes in the bracket here. It's 1 plus the 5%, 1 plus the rate of interest. And I'm not going to put an R, I'm going to put an I, and I'm going to explain to you why. Okay? To the exponent n, I'm not going to put a T, I'm putting an N. So with compound interest, sometimes interest is not calculated at the end of the year. Like in our previous example, interest is calculated many times during the year. Actually, not sometimes, a lot of the time. Okay, so there are n what's called compounding periods. So in the case of Fran, a compounding period was a year. It means every year she earns 5%. So this is the number of compounding periods. But compounding periods may not be a year. They may be shorter, and which I'm going to show you in the chart below. So the I is not the interest, it's not the annual interest rate, it is the interest rate per compounding period. So it's not the interest rate for the year, it's the interest rate for the compounding period. So let's show you what I mean. Okay, actually, first let's write the formula again. The future value and present value is referring to what will the money be worth in the future, and what is the money worth now or in the past. If we think the future is now, then what was the money worth in the past? So basically the beginning amount and the ending amount. I'm going to write that here. Future value is the ending amount. Present value is the beginning amount. Okay, so find the final amount when you know the principal. So if you know the principal, the future value, which is the same thing as the A, is just this formula that we've seen already. All right, but sometimes you will see that they're asking you for the present value. All the present value is the beginning amount, which is the P. So if you see the word present value, they're really just asking you for the principal when it comes to compound interest. Okay, so all we have to do, if you want, you don't have to, you can just use the same formula all the time, but if you want, you can rearrange the formula. And so you can isolate P. So P is equal to A over 1 plus I to the N. It's just rearranging the same formula. Or you can use the word present value. You might see this actually in the textbook. Present value instead of principal, same thing. And instead of writing it as a fraction, they will write the N as a negative exponent. So they'll write it like this. A times 1 plus I, but to the negative N. All right? Notice these are all exactly the same formula. So really, all you have to do is know this one. All right, you're welcome to make note of the others, but it's the same thing. All right, so let's talk a little bit about compounding periods. So compounding period is the length of time after which interest is calculated and then added to the balance. So annually means at the end of the year, so 1 time per year. Semi-annually means at the end of every 6 months, so 2 times per year. So the word semi means half. So that means every half year, so 2 times per year. Monthly is 12 times per year. Semi-monthly means every half month, so 24 times per year. Weekly, how many weeks are in a year? 52. Bi-weekly means every other week, so every other week, okay? And so every other week, and there's 52 weeks in the year, so every other week means 26 times. Notice that semi-monthly and bi-weekly is not the same thing. Half month and every other week is not the same thing because there aren't exactly 4 weeks in a month. All right, quarterly means 4 times per year, so every 3 months. Daily is 365 times per year. Okay, so now you have all the information you need to do problems that have to do with compound interest. So please watch the next video, which has an example of compound interest problems using these compounding periods. Thanks for watching.